video, I'm going to be solving the valid parentheses problem. I'm going to be going through logic, my thought process, and some coding of how to solve this problem. So let's start with the problem. Given a string S containing the characters left parentheses, right parentheses, left bracket, right bracket, the other left bracket, the right bracket, determine if the input string is valid. An input string is valid if an open bracket must be closed by the same type of bracket. The open bracket must be closed in the correct order. So actually, they're telling us what's right and what's wrong. And right off the bat, we have to tell the program what's right and wrong. Because what if they said this is open and this is closed? I mean, our program wouldn't know. So we have to have a way to mark that this is open, that this is closed, that this is closed, and that this is closed. So we have a couple examples. So this alone is open, and obviously it has its other character, so the other parentheses which it closes, so this is closed. These two are closed, these two are closed, and these two are closed, so the output is true. We have the left parentheses, but we never have a right parentheses, so it's false. But at the same time, if we have the left parentheses, the left bracket, and we put a right parentheses, this should also be false because it never closes. Because it says the open bracket must be closed by the same type of bracket, open bracket must be closed in the correct order. So it has to be in order. So the only way this can be closed is if there's another bracket right next to it. So those are kind of some things that right now, by reading the question, I'm getting from it. So we have to tell the program what's right, what's wrong, what data structures will we use. So I do want something where, because I have a string and they're giving me a string, something that I can, let's say, put a left parentheses, put another parentheses, put a bracket, and then let's say I put another one, and if it's closes, then I can delete them. I have another one, and I have another one, and I have another one, and then my new one comes in, and I just want to delete the one that's next to it, because it has to be in order. So, or if I have something like this, then the only way this will close is if something similar comes right next to it, then I can delete both of them right away. So just thinking about that, we can have a queue, a vector, an array, but to tell you the truth, what I'm thinking about right now is last in, first out, because I put this and I have my other bracket. So I think having a stack as a data structure will work out pretty well. The next couple of things that I'm thinking about are my base cases. One of my base cases could be, what if the string is only of length 1? So if it's of length 1, then it will never close. Because if it's just this or just this, then it will never close. So I'm going to here return false. And what if the string is empty? Well, if the string is empty, I do know that it is closed. So I'm going to return this as true. So right away, when my string comes here, it'll run these two, and it doesn't even have to run through my algorithm. So I have to tell the program what's right, what's wrong, what data structures I'm going to use, which is going to be a stack. I have my base cases. So actually, before we get to writing, my algorithm and my thought process is how to solve this, how can we tell the program what is right and wrong? Well, what I'm going to do is have a map with a key value pair. You don't have to have this, but I think those will be pretty easy to say that, hey, if the key is left parentheses, then I know that the next one has to be right parentheses. And I'm going to mark this as, closed. And I'm going to do this for the rest of the brackets. And also, and so pretty much this tells my map what's closed and what's open. So, and I'm marking them as key value pairs, so I'm telling the computer what's right or wrong. If right here they would have told me something else, I could change that easily. In my data structure, I do want a stack. So C++, I can just say stack, and I want it to be a stack of characters. So I'm just going to call it my S. And I'll pretty much what we're going to do is in the stack, we're going to have from this string, every individual index is going to go in my stack. So how are we going to do this? So I want to loop through my string. Just going to take about O(n) time because I want to go through every single item. Every single item in the string, I want to go through one by one and make those comparisons like I was doing up here. So I want to do that. So what happens? So, well, the first thing is if my stack is empty, then I just push a string to the stack. So doing an example, my stack is empty, so I just do this, and let's say it closes, and I get rid of this, then the next one is empty, so I just put a string to my stack. I just push a string to my stack. Then the other thing is it closes, then pop. So if no matter what, let's say this is my string, this new one, if the one right before it closes it, then I can just get rid of this one. And then I can have here else pop or else push. So if it's not empty, so if there's already stuff in here and it doesn't match, then I'm just going to push the next value. So no matter what, every iteration, unless it matches, I'm going to be pushing to the stack. So how would I write this? So I want to loop. So the way I'll loop would be have your basic loop should be I is less than. And then here is where I will write my algorithm. And I'm going to be making those changes to the stack. So in the stack is where I'm going to be writing the character. So like I did here, if my stack is empty, if it's empty, then return true, else return false. Because at the end, if it's true, all these will get removed from the stack. So the way I can just write this is return my S empty. Because if my S empty is true, is empty, returns true, and if not empty, it returns false. So I can just have it like that. So what I can write here is, so I want the loop, and it's going to loop through every single one of them. So the left bracket, the right bracket is, I'm going to do my stack is empty. So if my stack is empty, then I want to push that single character, correct? And how do I make sure that if it's closed, well, I can say, I'm going to say else if, and how do I know if it closes? So here I have left parentheses, left bracket, else if my character, so what I'm going to want to do is if the character matches with my string, so if the next one is this and it matches, then I'm not going to insert this anywhere. I'm just going to pop this one right away. So technically you just could do my s.pop because I never inserted this. I'm just going to pop what's on the top. Make sense? So technically cars, my s.top, so which is this left bracket. So if left bracket cars, which is technically right, is equal to the new one that came in. If it's equal, then that means it's closed. So I can just pop this one right here. So then these are gone. And then that's about it. And then else, I'm just going to push. So starting from the beginning, let's say we have this right here. Let's say I have, it's empty, so it's going to push this to my stack. The next iteration is not empty, so it's going to go here. If cars, which is, this is a string, which is si, but I want to look what's at top. So this is technically my s.top. If that equals si, and so when it goes to the character, it sees that it's that, which is true, then it's going to pop it. So now it's empty. Then the next iteration is going to be the left parentheses, is going to do the same thing over and over and over. So actually what we're going to do is run this and see if it works. Here, we don't have. So I'm just trying to see probably some error somewhere. Wait, expected. Oh, I see it. So let's run this. Let me submit it. So you can see it worked. My runtime, 100%, C++ submission. Maybe I could have done differently with memory, but that's just an intuition of how I did it. Also, one of the things I could have done too, if you think about it, is every iteration I'm just doing push or pop. Like, why do I have to have two pushes here? Well, technically in C++, I have to check right away if it's empty. Because if I just say, if this and else, because else is not empty or otherwise, then I can get an error. So that means that this push would have to be in the top. So I can actually say, if it's empty or, so if it's empty or is not closing or it doesn't close, because I have to do the opposite, then push, else pop it. And when I submit it, it goes through. So that's a little simpler way, but the way I solve this is O(n) time, which is literally which is gets the string, just goes character by character in the string. And that's it. If you guys have any questions, let me know. Thank you.